thank you to EuRuKo for having me here. For me, it's an honor to be in this huge stage, sharing with this amazing community that I love so much. But well, I know that maybe the majority of the people here are maybe wondering, who is this guy? I want to take a little bit to properly introduce myself. My name is Rafael Peña Azar. I'm from Colombia, from a city named Santa Marta, pretty far away. If maybe my name sounds a little bit familiar to you, I'm known in almost every social network as RPA Web. I'm married. I have two beautiful kids, Benjamin and Nicholas. There you go. And I've got a lot of roles in my work experience, but in general, I consider myself as a programmer. It's the term that I like the most. I have almost 15 years doing software development, and 12 of those 15 years are with Ruby and Rails. I sometimes do public speaking. I've been a teacher from some universities back there in Colombia. Did some conference in the past too, some RubyConfs in Colombia too. But I'm pretty sure none of them is like this one. I'm also a technical writer. We're going to agree that we like a very well-structured documentation. But also I love to write technical articles. Recently I started a kind of series of articles called Ruby Out Rails in my dev profile, where I talk about basically powerful things about Ruby without Rails. Things like generic algorithms, machine learning, blockchain. I'm also an aspiring solopreneur. I don't know if many of you are familiar with a project that I'm building called Skeletor. And the thing is not to spread the word with it, but I'm kind of mentioning it because I use Crystal too in that project. I'm also back in Colombia. I'm considered like a Ruby and Rails evangelizer. That's because wherever I go or every company I worked for, I always end up talking about Ruby and Rails, and at some point they end up making something on Rails, or even rewriting existing projects with Rails. And what else? I found Ruby Santa Marta in my city. It's a Ruby user group based on that city. And besides, I consider myself as a Crystal enthusiast. I'm not consider myself as an expert, but I need to address that it's a project that moves me and makes me want to contribute at some point. I know it takes maybe a lot of courage to being here in a Ruby conference and talk about another language, but I will try to make it the best way. I want to start with a little poll, and please raise your hand if how many of you have even heard about Crystal language. Awesome. And how many of you have developed something on Crystal? Less. And after that, I would like to ask if you know frameworks that are based on Crystal language. Okay. Well, that message is a little powerful for me because I didn't cross the Atlantic to come to the largest Ruby convention in Europe to tell you to stop being Ruby developers. It's kind of foolish. I'm just another enthusiast guy about a language that it's highly influenced by Ruby, and I wanted to share with all of you that this language exists, that it's very, very well maintained, and also it's not my intention today to go very deep about comparisons, because the goal of this talk is not about saying at the end which language is better. It's not that's not the point. The goal is to explore how Ruby have influenced the creation and the evolution of Crystal, and show maybe their similarities and some differences, and reflect on what the future may hold between both languages. So let's talk about Crystal language a little bit. The work on the language began in 2011. The Crystal compiler was first written in Ruby, then later written in Crystal, becoming self-hosted in 2013. Its first official version comes in 2014, and in 2016 became a more mature and more stable, encouraged its adoption and in more serious projects. Fast forward in 2021, Crystal reaches version 1.0, and marking the first official stable release and indicating that the language was production ready. And now, talking about this year, Crystal's popularity continues its rise, especially in areas where performance and efficiency are critical, while keeping Ruby's elegance. But let's talk about what is Crystal. Well, in a compressed definition, basically it's a high-level, general-purpose, object-oriented, compiled programming language with static type checking. Was started by Ari Bonenswijk and Johan Wagnerman with the idea of creating a language that combines the elegance and the simplicity of Ruby, but with the efficiency and the speed of C. Although Crystal and Ruby share a lot of terms in philosophy and syntax, they are maybe key differences. Crystal is statically typed, allowing it to deliver maybe C-like performance, while Ruby is a dynamically typed interpreted language optimized for developers' productivity. But from the beginning, Crystal syntax was designed to feel familiar to Ruby developers. And well, let's take a look at some code. Can you please, someone, find a difference between these two pieces of code? There's the same class and the same method, even the same response, written in both languages. But let's go into use an object-oriented structure to make that hello world in Crystal and see if we got some difference. Here we got the name variable declared now as a string, and it's not even necessary to assign anything inside the initializing method. But Crystal has grown its popularity and has even grown an active community. Projects like Kimal, like Ember, and Locky are helping to expand its ecosystem, making an attractive option for Ruby developers looking for something new, maybe some challenges. Crystal was designed to look like Ruby and making the code familiar and readable for Ruby developers. But this is not only makes the transition easier, but also allows Crystal to benefit from Ruby's rich history in language design. Let's talk a little bit about syntaxes. As you can see, both codes are almost identical, demonstrating the familiarity between Crystal and Ruby. And Ruby's readability and expressiveness were key inspirations to Crystal's design. Although the syntax is very similar, there are important differences in semantics. Crystal is a static type, again, checking language. And specifying data types not only improves performance, but also allow you to detect errors at compile time. Crystal adopts many of the Ruby's design principles. This makes Crystal code as intuitive as Ruby, but with an added benefit to optimize performance. Crystal adopts many of that's the design principles. But now I want to try to explain about that static type checking on Crystal, because it's a little bit different than other static type languages. Although Crystal is based on Ruby, the diverged on how it solves some problems. But what it means that it's a static type checking different than other static type languages. Let's start by addressing some of the terminology. Static type language means that the types are checked at compile time rather than at runtime, which helps catch potential errors early in the development process. This leads to improved performance, and as the compiler generates more efficient machine code based on the known types and increase the readability by catching type-related errors before the code is executed. But what's the difference with other static type languages? Crystal takes a different approach compared to some other statically typed language by emphasizing in readability and the developer's productivity. Remember, the influence is Ruby, and that's the way Ruby works. Here's how Crystal can achieve that balance. There are 5 items that we're gonna discuss. And Crystal has these checks that we're going to go through to understand a little bit more about it. And about type inference, Crystal, and this is very interesting, Crystal uses type inference extensively, meaning the compiler automatically determines the type of the variables and expressions based on their values and context. This reduces the need for developers to explicitly declare the types everywhere, leading to a cleaner, more readable code base. I always try here to remember how TypeScript works and make a parallel line between both languages. So this reduces the needs for developers to explicitly declare types everywhere. And in this case, the compiler infers that the value of a name string and the value of age are inferred that it's one of a string and the other one is a 32-bit integer, but without declaring anywhere. But there's the optional type annotations. So look at the code. While Crystal infers the types, as I was saying, it also allows developers to add type annotations where needed for clarity or to enforce strict type constraints. For instance, in this case, both argument and return types are annotated, which makes the function contract explicit. And this ensures that any misuse, like passing a non-string argument, will be caught at compile time. This is another interesting topic. Crystal introduces a type system that treats nil as a special type, not a regular. And rather than simply allowing any type to be nil, this means that you can accidentally assign nil to a variable unless it's explicitly allowed. This reduces common errors such as the null pointer exception that we are all familiar with. And for example, in this case, the question mark allows name to be nil in the case. If nil is not allowed, the compiler will raise an error, and if you try to assign nil to a non-nilable type. That's another interesting topic with Crystal, the union types. Crystal allows variables to hold values of more than one type using this called union types. This means that you can express situations where the type of in this case, the compiler infers that the type of the value is a string or a 32-bit integer. Can be both. And we'll keep track of the possible types and enforce correct operations on them. This also makes the code easier to understand because it conveys to the exact types expects in various contexts. Crystal's also static type works hand in hand with its friendly compiler error messages. If a type mismatch or a potential error is detected, Crystal provides feedback that is clear and helps developer pinpoint the issue without requiring them to sift through verbose complex messages. Crystal's static type enhance safety and performance through compile time checks while maintaining the readability through the type inference, optional type annotations, and the flexible union types. This allows developers to enjoy the benefits of a statically typed language without the verbosity typically associated with it. Again, always think about TypeScript and make the parallel comparison. But Crystal is not Ruby. So there's also points where Crystal takes total distance from Ruby, where they have nothing to do with each other. Let's talk a little bit about those unique features Crystal has. For instance, Crystal focuses on performance through native compilation and efficient concurrency mechanisms. Leverage fibers to manage concurrency, separating a little bit of what we know about Ruby's threads. So, again, Crystal is a compiled language. So, it compiles to native matching code using the LLVM compiler infrastructure. This means that the Crystal code is directly translated into a highly optimized matching code, which can be executed very efficiently. And native compilation allows Crystal to achieve near C performance for many tasks, as it eliminates the possible overhead of an interpreter and optimizes the general code. But I mentioned this word about 2 times. What's a fiber? Crystal uses this for concurrency. It's the key for concurrency in Crystal. Fibers are lightweight, cooperative units of execution that are scheduled manually by the programmer. And the difference with Ruby's threads is that they are memory efficient because they share the same OS thread and only need a fraction of those overheads of threads. Fibers are cooperatively scheduled, meaning that yield control explicitly. This makes context switching between fibers extremely fast. And because fiber doesn't involve context switching at the OS level, they have lower overhead. This little code demonstrates how fiber can be used to achieve concurrency in a simple and efficient manner. The spawn keyword is used to create a new fiber in Crystal. Every time we call the spawn, we make a new fiber. Okay, and now this is a term that I didn't mention before. In Crystal, macros are a feature that allows you to define code patterns which are expanded, let me show you, in actual during compilation. Macros in Crystal can be used for very many purposes, such as simplifying repetitive code or creating more readable and maintainable code patterns. Here is an example of how you might use a macro in Crystal. You define macros using the macro keyword. And the macro body contains a template code that maybe you are familiar with that will be substituted wherever the macro is used. For this particular example, the macro will generate 3 methods dynamically: the foo method, the bar method, and the bus method. In summary, macros are in Crystal a powerful feature for code generation and metaprogramming, allowing to write flexible and reusable code templates that are expanded during compilation. They help in reducing redundancy and automating repetitive tasks while providing a way to embed complex code logic in a concise and manageable format. Crystal is also especially useful in applications where it's critical, such as high-performance web servers or embedded systems. Let's see an example of a basic web server in Crystal. Okay, this simple web server shows how Crystal can handle some workloads with high efficiency. But let me see if I can just make it run for fun. Are you seeing? Okay. Better. Control P. Perfect. So let me see where I'm. Workspace. There you go. There you go. Okay, the web server. That's the same code I was sharing here. So let me close this a little bit and do it again. No, it's not tab, it's pane. There you go. And let's make it run. Crystal basic server. Okay, there you go. That server it's running, and you see the code right there and how they get the HTTP direction and put it into the server. Let's see another example. let's start with the hello word to see how we code in Crystal. Excuse me. Another example that it's the same about between Ruby and Crystal with the syntaxes. It's exactly the same hello world with Ruby and Crystal. So let's go and run Crystal. Hello, EuRuKo. There you go.
Can you please make it bigger?
I think not. But let me do one more and we continue. Let's see about the fibers. That's the same code I shared recently with the slides. And if I do Crystal fibers, let's see. There you go. So let me put it back. Well, we covered already maybe the comparison, how is the landscape between both languages. Let's talk a little bit about the future. Crystal is constantly evolving, and its community continues to grow. So the Ruby's influence here on Crystal is pretty clear, and the language itself is charting its own path into the future with new features and improvements. The future of Crystal and Ruby may be intertwined with opportunities for collaboration between both communities. And I make a stop here. I personally would love that to happen. The learning of one of them can enrich for sure the other one. And together it can continue to innovate in software development. So, remember that I started the talk with the same slide, but with a question mark at the end. Well, now, if some of you didn't heard anything before about Crystal, then now we just know a little bit. Maybe a little bit, but it's something. So I am replacing the question mark with exclamation point, and that has a reason specifically. If you're a Ruby developer and haven't explored Crystal yet, I encourage you to give it a try. It's a language that takes everything we love about Ruby, but has its own, how can I call it, keys to success in terms of performance and capabilities. Today, we explore how Ruby has shaped, or paraphrasing the name of the talk, has forged Crystal, and the similarities and the differences between the two languages. And obviously, there's more. But where they might be headed into the future, because Crystal obviously has a very bright future. Just to finish, let me say something. Crystal maybe it's not the only one, but it's a testament on how Ruby's inspiration has led into innovation. I think that's pretty much it. Thank you very much.